All right, so now I already told you a little bit about why we developed Giotto, but I just want to give you a quick overview before we dive in actual hands-on tutorials about what we have done so far. So I did tell you a little bit. So Giotto Suite right now is up on bioRxiv, and hopefully it will be soon be published in an actual journal. We're close, but not there yet. Just kind of like I told you before that I started this whole endeavor in 2018 working with Long Kai. That we got the first Giotto on GitHub in 2019. And then the layout of Giotto Suite, what I'm talking about right now, is actually something we started when I started my lab at Boston University in 2020. So that's 4 years ago. I first presented the whole idea, and I wanted to show you some of these like very early slides on an ISMB talk in July in 2021. So that's already 3 years ago, and we kind of like said to everyone, this is what we're trying to do, and it was really cool. And then recently in 2023, we actually got everything up and running, and we were really excited and proud about it, and still developing a lot more. So the idea, as I said before, is that we realized that compared to the early Giotto, it didn't really work well with the actual complexities of spatial biology, which happens at multiple scale. You have your bigger tissues, but then you have your niches, you have your single cells, and even down to single cells, you have your suborganelles and individual transcripts. Different technologies can capture different scales and can capture different types of informations. So we also needed ways to represent all that type of data that you can uncover from spatial omics technologies, including images, points, if you work with transcript data, intensities, and shapes. But we also needed a way that you could combine it in a very vertical way so that you can create this integrated connecto, connecting your genomes, epigenome, transcriptome, and so on, which all together really capture a phenotype. So in an ideal world, from a single tissue, we should be able to apply multiple different technologies and combine them and think about how everything is integrated and what we can learn from this like multi-scale and multi-omics type of technologies. And so that was really like our like high bar, like how can we make it as easy as possible for everyone to analyze and use this type of data set? I really like this little review from Anna Carpenter and Shantanu Singh. I'm just going to highlight one thing, and we're really trying to do this. So we're really trying to make usable tools, and they call the usable tools are the last mile bridge between what computer science makes possible and what biologists are able to put to widespread use in their research. So it's not just about making the new and best and shiniest thing, but also making something usable that people can use and can repeatedly contribute and use. So this was the original Giotto object where we could do all sort of different spatial downstream analysis. And now we kind of like switch to a more innovative software engineering approach where we have modularized Giotto into different modular packages that all together they combine us in Giotto, which provides you with a very integrative bioinformatics and spatial analysis. All right. So I already mentioned that. I think this is done. So what we kind of envisioned is that we separate how features are represented. So this can be RNA, protein, metabolites, ataxic data, if you have that, and how the spatial information is encoded. The spatial information can be single cells, can be your suborganelles, can be niches, can be a grid. It really can be everything. And so by combining these two, or by separating these two, you can combine them in multiple different ways. And so the features can be these points, intensities integrated, so can represent different technologies. Spatial units can be cell segmentations, can be arrays, can be nested queries as well. And so in this way, we can combine multiple technologies, combine multiple scale, combine multiple molecular analytes. In order to do that, we also had to create dedicated sub-object classes, and I'm not going to go too much in detail, but they make it so that it's like as flexible as possible. Including spatial data wrangling. So you can, for example, this is really essential if you try to do registration of different technologies and different data sets. And I think some of us will talk about this in one of the later tutorials. Also different ways how to join the spatial objects and how to aggregate data if you want to aggregate it and do some more like typical downstream analysis. The tutorials and examples, and many of them are also in our bioarchive in our preprint, which you can also look at, and we will touch upon some of these. We will give you both examples about multi-scale type of analysis, how to register and segment data, how to perform multimodal analysis, and how to work with how to try to do more scalable data and what we're working on in the future. In addition, and I think this is really important, we envision Giotto as kind of like as a community tool in the future where it's not just us, but everybody can contribute, but also where it kind of like nicely integrates with some other like popular tools that are out there, including like Seurat, SquidPy, spatial experiment from bioconductors. And also how it integrates with a very long history of R and spatial data analysis. As I showed you in a very early slide, spatial data science has been around for like already decades, and there's a lot of like really cool algorithms and statistical tools available that can almost directly be applied on spatial omics technology and spatial omics data sets. I just want to say we also have a website. So on the website, you can find a lot of additional information in addition to this workshop. If you find a bug, then please let us know. And if you're interested to contribute or you want to follow what we're doing, you can follow us on Twitter. You can email me or anyone else from the workshop. And then the last thing I just want to say, Giotto Suite has been a really big work in both my lab, so the Dries lab, as well as the UN lab, so GC's lab. It's been led by George in my lab and Jocelyn in GC's lab. But there are many other people that really did amazing work and helped us to get it where it is right now. And also a lot of funding sources that realized how important the work was that we were doing, including like the Chan Zuckerberg Initiative, Alex Lemonade's Sound Foundation, and others. And so with that, I want to conclude this part.